Hey guys, happy Thursday. So we have now finished our circles unit, and what we're going into next is we're going into area of composite figures. So we're going to talk more about what exactly a composite figure is at the by the end of this video. But in order to be able to find the area of a composite figure, we need to remember all of the area formulas for these following shapes. Okay, so we're going to quickly review these. These should be, we should remember how to find area of most of these from elementary school. So what I'm going to do is I'm going to go through each of these and we're going to write the formulas of each of these shapes and do an example together. So on the first one here, we have a square, okay? The area formula of a square is length times width, okay? Remember, the length is how long something is. The width is how wide something is, okay? So I'm going to label on my square here my length and my width. Now, using the properties of a square, we know that all of the sides are the same. So your whatever is here is going to be the same dimension on the width on a square. So the other formula you can use is A equals S squared. S stands for the side. So whatever the side is, you can square it or multiply it by itself because they are going to be the same dimension on a square. So my suggestion to you guys is if you want to pause this video and get out a sheet of loose leaf and write down your formulas for these different shapes, okay? Or grab some index cards so that you do not have to continue to refer back to this. So let's do an example here, okay? If we use the formula A equals side squared, my side on this example is 14. So I'm going to plug 14 in where my side is. Or if you use length times width, 14 times 14, because all sides are the same. So if we throw that in our calculator, 14, let me get it out of the light there. Let's see. 14 squared, or 14 times 14, equals 196. Okay, so my area of this square is 196. Remember, it's our units squared. So in this case, it's centimeters squared. So when you guys are doing area formulas, just like what we did with circles, there's going to be 3 steps. Write your formula, plug in the dimensions they give you, and solve. Okay, next one, rectangle. Okay, this one is very similar to your square. This one we're going to use A equals length times width. A stands for area. Length, how long something is. Width, how wide something is. So let's try a quick example here. Writing my formula first. My length, how long is my rectangle? 11 times my width, how wide is it? 6. And we should know this. 11 times 6, 66. This is inches squared. Okay? This next shape, okay, this is called a parallelogram. It's kind of like a tilted rectangle, okay? And I know some of you probably remember the word rhombus. That's like a tilted square, okay? So this formula is base times height, okay? And here's the thing. Your base is kind of like your bottom, right? There's your base. Now your height, be careful. A lot of kids want to use this. This is a slanted height. So when you go to measure your height, when you go to the doctor's office, you don't stand slanted, do you? You want to stand up straight, nice and tall to get your accurate height. So what you do on your height here, guys, is it's the height from the top to the bottom, straight down. So right here would be a height. Another height would be right there. That's also another height. Okay, so let's try an example here. Base, which is my bottom, is 7. Height, right here, is 8. Okay, on some diagrams, they'll give you what the slant height is. We do not want that, so don't get tricked up. 7 times 8, we should know, 56 inches squared. Anytime you're finding area, your answer is squared because you've multiplied 2 dimensions. So we multiply and put our answer to the second power. Okay, next shape is a triangle. Okay, a triangle, if I made 2 triangles, that would kind of look like my parallelogram up above. So you can see one triangle is half of that. So guess what my formula is? 1/2 times base times height. Okay, the other thing you can use, if you don't multiply by a half, multiplying by a half is the same as dividing by 2. So you can use base times height divided by 2. Okay, over here, to do an example, A equals 1/2 times base times height. 1/2 times my base of the triangle is 9. My height of the triangle, remember your height, it's not slant height. It's going to be the regular height there. Okay. In this case, it mentions it over here. My height is 6. And you can throw this all in your calculator. I'm going to show you the shortcut math here because these are all multiplication. That's your commutative property. What's half of 6? Half of 6 is 3. 3 times 9 is 27. And if we put that all in our calculator, we would also get 27. Centimeters is our unit, squared. All right, the next shape, okay? You can see this shape. This is this is a trapezoid. Either one of these is really a trapezoid. This is a regular trapezoid. This isn't called an irregular trapezoid. It just doesn't look as perfect or symmetrical as this one, okay? So here, this is probably the trickiest formula, okay? It is 1/2 your height, 1/2 times your height, parenthesis, B1, and my 1 is called a subscript. It's lower, not an exponent, but a subscript. And you don't want the 1 next to the B. It goes lower. Plus B2. What do all these things stand for? So 1/2 times my height. Remember, my height is not my slant height. My height is the dimension straight up and down. There's my height. Now, B1 and B2. So I bet you have a guess at what B stands for. Just like up here, it's our base. But why do I have to have a B1 and a B2? Because you'll notice that your bases, whether you turn it this way or you turn it upside down, your bases are different. This one is shorter than this one. Just like over here on the irregular one, this one is shorter than this one. So it doesn't matter which ones you label because we're going to add the 2 together. I typically do my base 1 up top, my base 2 on the bottom, and same thing over here. My height is either right here or you can find it right there. B1, B2. Okay, my base 1 and my base 2. So let's try one. I have a nice perfect example here. This one is symmetrical. So I'm going to write my formula, 1/2 times the height times the 2 bases added together. So let's plug in. My height for this one is 5. My base 1 is 3. My base 2 is 12. So I'm going to add 3 plus 12. If you did it the other way around, you're going to do 12 plus 3, which will still give you the same answer. You can now put this all in your calculator in one swoop, okay? I'll show you what it looks like here. 1/2, so you can do 1, ABC 2, or 0.5, times my height, parenthesis, remember those are right above your 8 and your 9. 3 plus 12, close your parenthesis, equals 37.5 or 37.5. If you convert that to a decimal, remember second fraction to decimal, decimal to fraction, goes back and forth. 37.5. Okay. And it's meters squared. All right, our last shape, this one we should become experts on, is our circle. Okay, area of a circle we should know by now, pi r squared. R is my radius. If they give you the whole distance across, that's called the diameter. Okay, so you would just divide by 2 if you're looking for the radius, the halfway. Okay, so let's try one quick example over here. This should be easy peasy after the stuff we've been doing recently. A equals pi r squared. And luckily we are given a radius. My radius here is 4. And you can put that all in your calculator. Okay, if they asked you to give your answer in terms of pi, it'd be 4 squared, which is 16 pi. Or, write in your calculator, pi times 4 squared. 50 point, we're going to round to the nearest tenth here, 3, because there's our 2. Number behind it is 5 or higher, so that gets bumped up to a 3. My units are meters squared. Okay, so these formulas are the formulas that you're going to want to use because we're going to start talking about area of composite figures. Okay,